All right, let's look at the homework 3.7, problem number 5. All right, so for a given function, we want to find all these things. All right, first let's find the x-intercept. We're going to set x squared minus 3x plus 4 over x minus 3 equal to 0. Right, then we need to set them equal to each other. So let's see, set the numerator equal to 0. So we're going to get, let's see, so this is going to give you x squared minus 3x plus 4. Right, and let's see if we can find the solution using a quadratic formula. So you have x is equal to, right, negative b, so it's going to be positive 3, plus or minus square root of, right, b squared, so it's going to be 9, minus 4 times a is 1, and c is 4. Right, and we already see that here this is going to be a negative number, so there's no real solution, so there's no x-intercept, so it does not exist. Alright, so y-intercept is easy because we just have to set x equal to 0. So put 0 in there, so it's going to be 4 on top, and the 0 in there, so you have negative 3. Right, so x is 0 and y is negative 4/3. Alright, so let's check the answer. Alright, so let's see, note that. Alright, so we got does not exist for x-intercept, does not exist, and the y-intercept is 0, comma, negative, what was it, 4 over 3, 4/3. Alright, so let's check the answer. Alright, I came back and it looks like we got the x-intercept and y-intercept correctly. Alright, so let's look at the relative max and the relative min. Alright, so to find that, we need to find the critical number. So let's go ahead and do that. So y prime is equal to, alright, so we're going to use a quotient rule here. Alright, oops, we don't really need this. Alright, the quotient rule, square the bottom, x minus 3 squared. Alright, then derivative of the top is 2x minus 3 times the bottom, so it's x minus 3 minus top, which is x squared minus 3x plus 4 times the derivative of the bottom, which is 1. Right. So let's clean this up. Alright, oops. Let's see. Yep. Alright, so if you multiply out, you're going to get 2x squared and minus 6x. I'm just distributing 2x. And then you have a negative 3x and a plus 9. So that's that. And then we're subtracting x squared plus 3x minus 4. Right? Then denominator is x minus 3 squared. Right? So we can cancel. Let's see. We have negative 3x and then positive 3x. Right? Then we can combine 2x squared and minus x squared. So we get x squared, right? And then we have there's only negative 6x, so it's going to be minus 6x. All right, then we can combine 9 and negative 4. So that's going to be plus 5. All right, so we have over x minus 3 squared. All right, then we can factor out the numerator. So I'm going to go here. Let's see, it's going to be x minus 1 times quantity x minus 5. All right, over x minus 3 squared. All right, so if you set that equal to 0, so you can see that we set the numerator equal to 0. So we know that the x equals 1 and x equals 5. All right, so let's do a number line, and here. All right, we have to put a tick marks for 3 too, because function is not defined there. So we have a 3 there, and then we have a 1, and we also have 5, so those are critical numbers. Then we just need to look at the sign of the derivative. So we try y prime anything smaller than 1. So I'll try 0. All right. So if you put 0 there, so the denominator is positive. So you have a negative times negative positive. Everyone's positive. So you have a positive here. We can try anything between 1 and 3. So we're going to try 2. Right. And if you plug in 2, so that's positive, negative, positive, so it's going to be negative. All right, if you plug in anything between 3 and 5, so we can try 4. So it's going to be negative, and it's also positive. This is going to be negative, so that's going to be negative. Anything bigger than 5, 6. 6 minus 1 is positive. 6 minus 5 is positive, so it's positive. So the original function y is going to be increasing here, and decreasing here, and decreasing here, and then increasing there, right? So you can see that here we're going to have a local maximum, and here we're going to have a local minimum, right? So let's see. So relative max happens here at the 1, and relative mean happens at 5. All right, all we have to do is a corresponding y value. So y of let's see 1 is going to be, let's see, put 1 squared is 1 minus 3 times 3 plus 4 over 1 minus 3 is negative 2. All right, so this is going to be negative 2, so positive 2, so it's negative 1. So we have negative 1 here. And y of 5 is equal to, plugging 5, so 25 minus 15 plus 4 over 5 minus 3 would be 2, right? So this is going to be, let's see, that's 10, 14 divided by 2, 7, right? 7, right? So let's type those guys in. So 1 comma negative 1 and 5 comma 7. Right, so I'm gonna get those 1 comma negative 1 and 5 comma 7. Right, so let's check the answer. All right, I came back and looks like we got both of these relative max and relative min correctly. All right, so let's find the point of inflection here. All right. All right, so we need to take another derivative. So let's go ahead and do that. So here, y double prime is equal to, right? So it's another quotient rule, right? Square the bottom. So let's look at this one here. All right, square the bottom. So it's x minus 3 to the 4th power. All right, derivative of the top, maybe I'll do that. Derivative of the top, let's see, maybe I'll do this one. All right, actually, derivative of the top here. So it's going to be 2x minus 6 times the bottom, which is x minus 3 squared, minus top, which is x squared minus 6x plus 5, times the derivative of the bottom, which is going to be 2 times x minus 3, subtract 1 from the power, so you have 1, and multiply by the derivative inside, which is 1, so I'm not going to write that. All right. Then we have something in common, so I will pull, let's see, I'm going to go down here. All right, so we have x minus 3 here, and there are actually 2 of them, so I'll take one of them. So I'm going to pull out the x minus 3. And also, this here, you have actually 2 in there. So it's a 2 times x minus 3. All right. So we can pull out the 2 as well. So I'm going to take out this 2 here and this 2 there. So I'm going to put 2 out here. All right. Then you have, let's see, so you have x minus 3 and x minus 3. So I'm going to multiply together. So it's going to be x squared minus 6x plus 9. Then you need to subtract x squared and add 6x and subtract 5. Right? So I took care of this guy and also those 2 guys. So that's everyone. And then divide by quantity x minus 3 to the 4th power. All right, so we can cancel x minus 3 on top, and then we scratch that and then put the cube there. All right, and also we can cancel x squared minus x squared, and then you have negative 6x and the positive 6x. And then 9 minus 5 is 4. So I'm going to combine with 2. So it's going to be 8 over x minus 3 cubed. All right. Then we can look at concavity. In this case, this guy is never 0. So we just put the 3 because its function is not defined there. All right, then we look at the sign of the second derivative at anything smaller than 3, so I'll try 0. All right, so you have a negative 3 cubed is going to be negative. Top is positive, so it's going to be negative. If you try anything bigger than 3, so I'll try 4. 4 minus 3 is positive. Everyone's positive. So we know that the original function y is going to be concave downward before 3 and a concave upward after 3. All right. So we think that there's going to be an inflection point there, but unfortunately 3 is not a part of the domain. So it actually a point of inflection does not exist. All right. So let's look at that. Let's see. Let's type it in. Does not exist. All right, so let's check the answer. All right, we got point of inflection correctly. All right, let's look at the horizontal asymptote. All right, horizontal asymptote, if you look at this, it's probably easy. So if you look at the original function here, so original function is here, right? Then when x equals 3, this guy is going to approach 3 is going to blow up. So x equals 3 is going to the, well, actually, I'm looking for the vertical asymptote right there. And then horizontal asymptote. Since this is a rational function, there's an easy way to find it. You can see that the degree on top is 2. And degree on the bottom is 1. So since the top degree is higher than the bottom degree, there's no horizontal asymptote, so that does not exist. All right, so let's type it in. All right, so it does not exist, and the vertical asymptote is x equals 3. All right, so let's check the answer. All right, I came back and we got a horizontal and a vertical asymptotes correctly. All right, so let's look at a picture here. All right, so we know that here the picture should be concave down turning into concave up, and it's going increasing, decreasing, decreasing, increasing. All right, so let's look at a picture here. All right, so this one, concave down, concave up, and the vertical asymptote is at 3, right? Then increasing, decreasing, decreasing, increasing. So that looks promising, right? Here, there's a vertical asymptote, but it's a decreasing, increasing, so that's not correct. So this one doesn't have the right concavity, and this one doesn't have the right concavity either, right? Oh, actually, wait a minute. Concave down, yeah, right. So we have, right, so the correct picture is this one, right? So let's check the answer. All right, I came back and looks like we got the correct picture as well. All right, that's it. I hope that this was clear.